take a look at Node.js and install it, as well as look at some fundamentals. So if we go to nodejs.org, it has a download section. The current version is 20.11, and this has the installers for all your various devices, Windows, Mac, Linux. I've already installed it. You can quickly double check your version with node -v for version. I'm running on 20.5.0. And npm comes for the ride as well. Node package manager. But in order to get started and start using Node and installing some packages, we need to run npm init. This will create a package.json file for you, which will allow you to do installs. I'm just showing you how to get set up with the initial package.json, but you could run npm init -y, and it'll skip past all this part here. Really, what the package.json does here is, if you wanted to create your own packages and you wanted to author them, this name of the package, version, description, and author, all those things, is what would be shown in the npm registry. But we need this package.json, and we need it to work with npm because it'll allow us to install third-party modules. Our entry point for our little application will be index.js. And remember, we're using JavaScript on the server level, but it gets transpiled down to machine level code. We're just trying to keep consistency from front end to back end with the same language. Just keep a note of that. So we want to install a module called Chalk. This is third party. Just to show you what a third-party module looks like. And this will, if you look at the registry itself, this is where all the packages lie. Chalk is a good example of a one that's well documented. What it will do is just give some coloring to console log. One thing to note here is, by default, this is actually using it's configured using ES modules. So it out of the box, Node uses CommonJS, which uses the require statement, and that's one fundamental, is that it's a little bit different than front end, in that everything we've been doing with React and those languages use the import statement to pull in the logic, whereas Node out of the box uses require. So here we're pulling in a built-in module that comes with Node for managing file systems. It's called the FS module, and we can just pull it in via require, and it's good to go. So that's one module is built in. The other one is custom modules. Custom module is going to create today. We're going to create today, and we're going to create our own logical piece of code that can be reused, and we're gonna make it public, and we're going to import it into our main caller application. So we don't have that set up, but we'd like to set up something called my module. So there's two built-in, and there's custom modules, and obviously the third is the third-party packages for npm. But anyhow, the entry point, we're going to run node and the file name, and this will kick off and say, hey, there's an error here. We don't know where my module is. So we need to go and create that, and we'll just create it in the root of the file. And it's going to be called mymodule.js. And if you notice, though, the Chalk, if you look at the left there, Chalk installed, when we installed Chalk, that Node modules got created, and that holds all the dependencies needed for those third-party packages, by the way. So we're just creating a function, my function. It's going to just console log out, and it's going to console log out that it's been called. And then we should probably add a variable as well. So we have one function, and we'll have a variable inside of our module. And what we'd like to do over time is build this out, and then reuse the logic and the variables anywhere else. So you could think of this like you could have a tax module, and inside the tax module is everything related to taxes, and all of the different kind of tax rates and all those things are contained. So if we run node index.js, it's going to register everything fine. There's no errors, which is good. Now we want to try to invoke and call some of these things that we have in that module. So we want to call the function, and we call a variable. And one tip is IntelliSense isn't picking it up for us. So if we do my module.myVariable, you'll see it's not defined in our IntelliSense. So that could give us a little bit of indication that maybe there's something wrong. with how we wired things up here. So if we run this, we're going to get not found. My function is not defined. And there's a reason for this. Module does a good thing of encapsulation and only exposing out, much like classes, what we want. So we need to use something called export, and we need to export out these functions similar to how we did it with React, with exporting out the defined functional components. So if we make this public, then when we call the caller, we should have access to everything. You can see custom module was called, hello Node.js was the variable. So now we have access to this, and we can decide what we want to reveal and what we want to hide. We can keep a lot of things internal and only hide, only make public the pieces of our module that make sense for entry points. But things like tax calculations and things like that might be kept hidden because we don't want people to overwrite them. Just note, there's a couple different patterns you could do to export. At the end of the day, that as long as they're public, that is all that matters. You can create an object literal and wrap the whole module logic inside of this export statement and build that up. That's one way of doing it. If you get tired of directly exporting out every single artifact in the module, so you could do that. There's like 10 different ways to do this. At the end of the day, as long as it's public, it doesn't matter too much, whatever your preference is. Just know if you're using an object, you have to use key value pairs if you're defining it inline. Easier way to do it, I'll show you in a little bit, is just to define all your functions and methods and all the pieces in your module, and at the bottom do a module export and just export out the whatever you need by name, like named reference. So if you had module.exports and just my variable instead of defining everything inline, we'll show you that when we do the next module. But anyhow, as long as it's all accessible and it's working, that's all I have to say about patterns in general. You just pick one that works for you. Because we'll do another one here. We'll show maybe we need a calculator module, so we'll create a math module, and in here we could add, add, subtract, division, multiplication, but we'll add squaring, just a little function for squaring, and then we'll show you how to export out by named reference, just slightly a little bit of a different export pattern. Anyhow, we'll take a number, we'll square it, number times number. And then this is where we'll use module, not modules with an S, module singular dot exports. And then here you can just by named reference just square. You don't have to define it inline. I like this pattern the best, to be honest, but because for me I can build out everything and at the end just expose what I want to expose. So we have a custom module, a second one called math. We want to input it in with our fundamental for require. So two fundamentals, requiring and exporting, and creating custom modules with export statement. Those are two fundamentals that we're learning right here, as well as the different kind of modules in Node.js. So here we have our module, my module and math module, and we want to just use the second math one. So we're going to do math.square, pass it a variable, and then it'll be defined in the answer, and then we can quickly console log out. This is a basic example, but you can see, if you organize your code in a certain way, you can build out very big logical pieces. And what the main point about that is if suppose we have math version 2.1, we can come in and swap in, take out the old one and swap in the new one without having to really jumble a lot of this main logical page here. So it's for reusability. So you can see that it's working here, and as we build our application out, this will become more and more important for bigger applications. Like I said, you could have 5,000 lines of code in this index.js, but if you're working on a team, maintainability becomes a very big problem, especially with merging and all of those things, and it just becomes a little bit of a nuisance, to be honest. Yeah, everyone's working in one file, so you can it's best to organize your code in the right way. So I'm just showing here chalk. It has background names and different things. I'm trying to use console.log here, which is not going to work. But really, what it does is if you wrap console.log chalk.backgroundcolor.blue, it'll give you some coloring, but it's going to complain here because, like I said, it's built for ES modules using import statement. In order to make that work, you need to tweak your environment, your node server a little bit, and then you can get that to work. But always refer to the documentation. But out of the box, we use require. And for now, we'll just remove this package. I'll just show you what would happen if we did try to import it via ES modules. It's going to give you this cannot use import statement on a module. And basically it's saying there, ES modules are not configured. So there's a little bit of a step to make your node work in that way. And just know, I want to show this example, is that your node server is highly configurable. We're showing you what to use out of the box, but you can install packages and do configurations to make this environment work the way you want it to work. A little bit beyond this tutorial though, but I just wanted to show that. So anyhow, the third fundamental I want to cover is called emitters. Everything in Node.js is event driven. Every built-in module has a wrapper around event emitter. And really what that is at the end of the day is there's events that are being fired, events that are being listened to, and it's a very event-driven architecture. So anyhow, we can use this built-in module from Node called events. We're going to require it in and create a variable called event emitter. You're just going to create a copy of it. You can do this in two ways. You can either just create a class and extend it, or you can create a variable and use event emitters.events. There's two ways you can set up. But here we're creating our own event emitter class here, and we're creating our new instance, so new custom emitter. And then once we have this set up, we have access to everything that parent event emitter class has. So first thing we want to do is we want to register an event that we're going to listen to. So we're going to register an event called custom event, and this function will take a named event, which is the name of the name there, custom event. Just note that this is a string. It's very case sensitive, and what that means is spelling matters, casing matters, because there's a lookup table internally. If you fire the wrong event, it will not match it up. So it matters when you're calling these events. Second thing to note is this listener.on has a callback, and that's going to be deferred until the event is fired. So we're going to have this anonymous function inline. Here, you could also put a named function in there, meaning this would be defined outside, and you plug it in, like callback, call. You would just plug it in here inline. This is just going to fire a console log, but it's going to be registered in memory, and we're going to export out our whole emitter here that has the listener attached, and that's going to be imported into our main program. And what that does is when we pull this in here, we have a mechanism that's listening. This could be something like a database, a logger, a database emitter, something that could happen, when database or connection closes, we want to do something, right? We might build out all that logic. Maybe we need to do backups or delete files or something like that. So anyhow, we pull in this custom emitter. In our code, we want to use it somewhere. We want to trigger that event. So the other mechanism here to trigger is called emit. It's in Angular, it's similar to something called broadcast. But really what we want to do is we just want to send the trigger. We have the listener registered. The event is registered. And there's this anonymous function that is waiting to be executed. So what we're going to do is we're going to trigger that. Just a second. But just remember that, we can we can have multiple event listeners registered for this custom emitter we created, and we can have multiple callbacks that will be registered as well. So we can have a complex logic in there that is being deferred. So here we're going to trigger it using custom emitter.emit custom event. I'm purposely putting this in lowercase. I just want to show you that if I run this using node index.js, it'll not fire. Why? Because, well, here we got to get rid of that chalk third-party reference, by the way. We'll just comment that out. Clear the console here, and then we'll run this again. And then we'll see nothing happened because we called an event that was not registered because we misspelt the name event. So we need to make sure that it's actually exactly the same. Custom event, camel cased, first words lowercase, next words uppercase, first letters uppercase, and you can see there custom event was emitted. So we triggered an event, and we can trigger multiple events, and events can trigger other events. So there's a lot of things we can do with this third fundamental. So, recapping, we use custom modules as a way of containerizing our code. We talked about the other 3 types of modules, built-in, third-party modules, and our custom module. And we're just showing here using our math module in a different reference. We also talked about event emitters and how Node.js is very event-driven. And we can containerize our modules with logic, and then also we can also add event listeners within them and trigger them via events when we need to, instead of directly invoking them.